Okay, today we're going to be talking about translations and reflections. In this lab, first what we're going to do is we are going to take a piece of graph paper. We are going to fold it in quarters to make our quadrants. Now this is very important. Make sure that the very edge of your paper isn't necessarily aligned, but make sure the line for the graph paper is exactly on the crease. That's very, very important to this lab. Once you're sure that that's directly on the crease, just make that nice and sharp. And then do it in the other direction. This is going to serve as our X and Y axes. So you should have something that looks like this to start. Next, what we'll do is we will darken in our axes. And again, I'm darkening this in right on the fold that I made in the paper. So we have ourselves an X and a Y axis. What we'll do next is we're going to start in quadrant number 1. Remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We're going to start in quadrant 1, and we're going to make some sort of shape. The simpler your shape is, the easier this lab will be to complete. The more complicated your shape, the harder it'll be, but the cooler it'll turn out looking. But for our purposes right now, I'm just going to do a parallelogram. So I'm going to make a dot here. You can make your dots anywhere you want. 1, 2, 3. Okay, so I'm going to connect those dots, and I'm going to make myself a simple parallelogram. Like that. So now what you want to do is you want to take a pair of scissors and you're going to want to cut this out. You're going to make a hole in there. My suggestion is to tear a small hole in the center of your shape. Oops. And cut right along your lines. Try to make sure you cut a little bit outside the line too, because when we fold it over, we're going to see that it's going to reflect onto our other axes. So I want to cut a little bit outside the line. So that piece I have to snip. And this piece I have to snip as well. That should be good enough. Okay, next what you're going to do is you're going to take your piece of paper and you're going to fold it in one direction. And what you're going to do here is you're going to take this hole that you just cut out and you're going to trace it. Be very careful with this. Trace it directly onto that other side. It doesn't matter which direction you fold it first because you're going to be doing it in both directions. So you should have something that looks kind of like this. If the dots don't exactly go directly on the line, make them. Sort of force them up into the other side. So we're going to have something that looks like that. Then what we're going to do is we're going to fold it in the other direction as well. Fold it down and do the same thing. This one will probably turn out a little bit better. Again, the lines are not completely set up, so I'm going to force them onto the line. That was just because of our cut in the beginning. We didn't quite cut it perfectly. Okay, so you should have something that looks like this. And what you're going to do now is you are going to actually find all the coordinates of each of your points. And my suggestion is to find your coordinates, put them directly next to each vertex of each figure that you made. So right here, for example, we'll start with the quadrant number 1, and we'll see we went over 1, 2, 3, 4 spots. 1, 2, 3, 4, 5, 6, 7, 8 spots. So this will be 4, 8. The next one we know is 8 up, but we went 1, 2, 3, 4, 5, 6, 7, 8 over and 8 up. So this is 8, 8. This next spot up here, we're going 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is at 7, 12. And this last part down here is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, comma, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 13. So this must be 7, 13. Okay. So we have our first quadrant done. And what we're going to do is we're going to count the spots for the other ones as well. And you should notice something about these spots and how they're related, how each coordinate is related. So this one, for example, this is in quadrant number 2. This was quadrant 1. This is quadrant 2. This down here is quadrant 3. We didn't do anything in quadrant 3. And this one is quadrant 4. So let's take a look at quadrant 2. So our first vertex is at 1, 2, 3, 4. So we have negative 4, comma, 1, 2, 3, 4, 5, 6, 7, 8. This next vertex down here is at 1, 2, 3, 4, 5, 6, 7, 8. Negative 8, comma, 8. The next one is at 8, 9, 10, 11. So this will be negative 11. And this is going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And our last vertex is at 1, 2, 3, 4, 5, 6, 7. That'll be negative 7, comma, 13. Let's take a look at this last piece down here. So let's count our vertices again. And we have 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8. So this is at 4, comma, negative 8. Remember, the second value is the y value. We're going down, so it's going to be a negative 8. This next vertex right here is at 5, 6, 7, 8. So we have positive 8 moving in the right direction. That's the positive direction. And down 8 spots, so we are at negative 8 again. Down here, let's take a look at this vertex. We have 1, 2, 3, 4, 5, 6, 7. We moved positive 7 spaces to the right. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Negative 13. And our final point is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We moved 11 spaces to the right, and we know before we counted 13 spots down. So what you're going to do next is you're going to create some sort of relationship between the vertices. I would recommend labeling all your points, starting in quadrant 1. This will be vertex A, this will be vertex B, this will be vertex C, and this could be vertex D. When you reflect it across the y-axis, this axis right here, the vertical axis, this is A prime. Then we notice that this is B prime. This up here is C prime. And this right here is D prime. Because when we fold this over, okay, you'll notice that this was A, this was B, this was C, and this was D. When we fold it over, we have A prime, B prime, C prime, and D prime. Similarly, down at the bottom, when we reflect it across the x-axis, down here we have A, let's call this double prime, and let's see what we do here. We fold this over, notice we had on the back our A, B, C, D, so we can tell exactly where everything belongs. This was A double prime. It makes this B double prime. It makes this down here C double prime, and this down here D double prime. Now what you can do is you can tell the relationship between any two vertices. For example, point A to A prime. We reflect it across the y-axis. Well, what happened to the values? You notice that the x value actually went negative. The y value stayed exactly the way it was. Similarly for B to B prime, 8 and 8 go to negative 8 and positive 8. Again, the x value changed signs, and the y value stayed exactly the same. You can see the same thing for C to C prime and D to D prime. Okay, so we have actually proven the rule here that when you reflect across the y-axis, we have x, y that go to negative x, positive y. Well, what happens when we reflect across the x-axis? Well, let's see. When you go from A to A prime, the 4 and the 4 stay exactly the same. The x's stay the same. This time the y changes, so we have 8 to negative 8. Similarly for B, 8 to 8 are fine, but the second 8, the y value in B, moves to negative 8. Let's take a look at C. C, you have 11, 13. When we reflect across the x-axis, we actually get 11, negative 13 down here. So our rule for reflecting across the x-axis, remember that's when you fold the paper horizontally, our rule is x, y goes to x, negative y. So that's the basis of the lab. See if you can do the rest of the questions on your own. If not, I do have some tutorials for you in the videos that are to come. Okay, thank you.